Welcome to ABCD. Today, we'll be solving another math question. Today, the question is, at 9 p.m., a wafer started moving towards the heart at uniform speed of 50 kilometers per hour. Earlier at 10 a.m., an ice cream started moving at a constant speed on the same road. So now we are having two food that's moving, okay? Yeah, it's quite cute. Okay, so we have a wafer. So a wafer looks something like this. Okay, my drawing is not very nice, but anyway, we have a wafer started moving to the heart. Okay, the heart. Okay, at 9 p.m. at a uniform speed of 50 kilometers per hour. Okay, the ice cream, they didn't give too much info. Never mind, we'll read first. They meet at 1 a.m. And the ice cream reduced her speed by 5 kilometers per hour for the rest of the journey. At this point, wafer has traveled 2/5 of the journey. It's somewhere here. Okay, so when wafer traveled 2/5 of the journey, wafer and ice cream met. Okay, then ice cream minus 5 kilometers per hour. Okay, if the first part is 2.5 of the journey, then this part will be 3.5 of the journey. Okay, 1 minus 2.5 is 3.5. Okay, so the first part asks if the ice cream is traveling towards the wafer from the heart. So part 1 says ice cream starts moving here. Okay, then at what time would the ice cream reach the wafer starting point? Then the second part asks if, let's say, the ice cream started moving in the same direction, then at what time would the ice cream reach the heart? Then the last part asks what's the time difference. Okay, so with this, we are going to calculate a few critical timing first, which is what we understand. Over here, we know this is 10 a.m. and we know this is 10 a.m. Okay, so let's calculate a few critical timing first. The first timing will be 9 p.m. to 1 a.m. Okay, so at 1 a.m. they meet, right? So 1 a.m. is here. So 9 p.m. to 1 a.m. this is 4 hours. Okay? Then the second timing we need to find out is from 10 a.m. to 1 a.m. And this is 15 hours. Okay, so basically the first part calculate the time taken for this part. So this is for this part. Okay, so the second timing that we calculate this is actually equals to this part for part 1. Okay, and this part for part 2. Okay, that's why they are common timing, so we can do the calculation first. Okay, so let's do part 1 first. So for part 1, we can find out the distance by W, which is wafer, to be equals to 4 hours because he traveled 4 hours. And 4 hours times 50 kilometers, and this will actually give us 200 kilometers. Okay, then the distance of ice cream will actually be equals to 200 divided by 2 times 3. Okay, because it's 3/5 instead of 2/5, that's why we get 300. Okay, then for the speed of ice cream will then be equals to 300 divided by the time taken, which we just explained is 15, and this will actually give us 20 kilometers per hour. Okay, then the new speed of I will actually be equals to 20 minus 5, and this will give us 15. Therefore, the time taken of I will actually be the remaining distance, which is 200, divided by 15. This will actually give us 13 and 1/3 hour. Okay? And this is actually equivalent to 13 hour, 20 minutes. Okay, then the next part. If we assume that the ice cream travels in the same direction, so what will change? Okay, the first part that will change is we will realize that the distance of I will actually be equals to the distance of W, and it will actually be equals to 200. So this is the first part that changed. Okay, because there's a change in this distance, so we can find out the speed of Y, which is 200 divided by 15. This will actually give us 13 and 1/3 kilometer per hour. Then we can find out the new speed of I, which will equals to 13 and 1/3 minus 5, and this will actually give us 8 and 1/3 kilometer per hour. Okay? Then the time of I will actually be the remaining distance, which is 300, because now if we travel in this direction, you will realize that he will travel 2/5 at the start and 3/5 at the later stage, which that's why the distance is 300. 300 divided by the speed, which is 18 and 1/3, and this will give us 36 hours. Okay? Okay, then part 3. Part 3 asks, what's the time difference between part 1 and part 2? So for part 3, the time difference, right, will be equals to 36 hours minus 13 hour and 20 minutes. And this will actually give us 22 hour and 40 minutes. So the same question, once we change direction of one of the route, we realize that there's a time difference. So in math, you need to be very careful to the details of what they write in terms of who start from where. Okay? Okay, part 1, right, from here, we can calculate that 13 hours and 20 minutes after 1 a.m. would be 2:20 p.m. Okay, as for this, 36 hours, it would mean 1.5 days. That's why it would end up become 1 p.m. the next day. Yes, this should be the answer. So 2:20, 1 p.m. the next day, and 22 hours and 40 minutes. So if you do a check, right, you realize that the time difference between these two is actually less than 1 day, which is about 22 hours and 40 minutes. That's it for this episode. We hope that you have learned something new. The link to the worksheets are available in the description below. See ya!